Okay, so today we're going to start looking at a new function called exponential function. And the way we're going to do that is you're going to graph the two functions given here in your do now. So at this point you should have your notes packet opened up to day 1. And what I want everyone to do right now is type the function 2 to the x power into their y equals. And what you're going to really be typing in your y1 is 2, and then you're going to use the caret button and put x in the exponent. Once you do that, I want you to go to your table of values, and I want you to find the values for y when x is -3 to +3, and I want you to plot them. So right now I want you to pause the video, and I want you to plot both y equals 2 to the x power and then y equals 1/2 to the x power. Same thing down here. When you type this into your y1, you're going to make a fraction 1/2, and then you're going to raise it to the x power. And again, you're going to make a table of values from -3, and this one we're only going to go up to 2 in the table that I provided for you here. But notice how the first graph is asking you to graph from -3 to 3, and the second one is just saying to graph. So you really can plot as many points as you'd like. Okay, so pause the video, plot your graphs, and then we'll check back in. Okay, so I'm going to pick right up as if you had graphed them, and they should look like this. So notice in the first graph, we were graphing some points that weren't whole values, and that's okay because we're taking some negative values and we're putting them in our exponent. So that is going to create some values less than 1. But you'll look here for -3. When you raise 2 to the -3rd power, you get 0.125, and we're just doing our best to try to plot that point. So it might have even been easier to start at the end of your table and plotted the point, let's say 3.8. So that point is up here. And then the 0.24, that point is here. 1, 2, that point is here for me. 0, 1, that's our y-intercept. And then these points, -1, 0.5, -2, 0.25, and -3, 0.125. You just do your best to approximate them. But this graph, we were only asked to graph from -3 to 3. So your graph should not have arrows on it, and it should look something like that. Okay, let's look at the second graph. Now we are graphing, this is also an exponential function, and we're going to talk about what that means in a moment. You are raising 1/2 to the x power, so now we are going to start graphing on the left. So you should have had the point -3.8, -2.4, -1.2, same y-intercept of 0, 1, and then we do have some decimal values going off to the right, 1, 0.5 and 2, 0.25. Now if you had looked at this graph on your calculator instead of going right to the table, if you had actually hit graph, you would have seen that the graph does look like it goes off to the right here. So for right now, you can just put an arrow. It's getting really close to the x-axis. And on the left side, you could just put an arrow going off. Because again, this direction for number 2 just said to graph. It didn't say to graph from one number to the next. So the first graph, no arrows. Second graph has arrows. Okay, so now what we're going to do is we're going to talk about what this function actually is. So if you could turn to the next page in your notes, this is what we call the standard form of an exponential function. And exponential functions are all about multiplication. So that's the focus we're going to have right now on this function, is that what it does is it creates values through multiplication. So what I want you to label right now is this b value. So if you'll notice, we saw 2 different looking graphs in our do now, and one was when we took 2 and raised it to the x power, and one was when we took 1/2 and raised it to the x power. Now just to recall, when we took 2 and raised it to the x, we had a graph that looked something like this. And when we took 1/2 and raised it to the x, we had a graph that looked something like this. Now I know our 2 to the x didn't have arrows on it. I'm just adding arrows now, just for the general graph. So if we had to think about our increasing and decreasing from last unit, we would say that the graph 2 to the x is increasing always. Because if you look at it from left to right, it's always going up. So what I want you to write here is for increasing and decreasing, it's going to increase when your b value is greater than 1. So let's actually describe what this b value is. Sometimes we'll refer to it as the base of the exponential function, and we also call it the multiplying factor. So if we go back for a moment, the multiplying factor. So when we had a y value, let's just start at 0. When our y was 1, right, and then we went to the next y, we multiplied by 2. Then we went to the next y, well then 2 got multiplied by 2 to give us 4. Then we went to the next y, and we multiplied by 2 and we got 8. Technically it was happening up here too, but you're just not as familiar with these numbers. If you took 0.125 and times it by 2, you would get 0.25. 0.25 times by 2 is 0.5, which is a half, and a half times by 2 is also 1. So that's why we call that number, the 2, the multiplying factor. Now, same thing is happening in this graph, except we're multiplying by 1/2. 8 times 1/2 is 4, 4 times 1/2 is 2, 2 times 1/2 is 1/2, and so on. So when that multiplying factor is a number between 0 and 1, so it's smaller than 1, like our second graph in the do now, the 1/2 raised to the x, that is going to be a decreasing exponential graph. Before we look at A, I just want to add one more thing. Sometimes when we call an increasing exponential graph a different name, we call it exponential growth. So if you want to label that maybe next to either b is greater than 1, we could call this exponential growth. Again, growth is just another word we're giving to increase. And another phrase we use instead of exponential decrease, we'll call it exponential decay. Okay, and then the other number that is in our standard form of this function is if there's a number in front of the base, which in our two functions, really there was no number written, so we could just say there was like a 1 in front, right? That's the coefficient we always say is there if you don't see it. So that 1 number is going to be referred to as our y-intercept. And if you look back, both of our graphs had y-intercepts of 1, so that clarifies that, or that at least shows you that this number is indeed the y-intercept, because both of our functions had a 1 in front of the base. The y-intercept, and sometimes we'll refer to that as the initial amount or the initial value. Okay, so now let's try a couple questions. So which of the following functions would best describe the data in the table below? So let's look at our y values for a moment. Now, when we look at linear functions, which is what we really see here in choice 1 and 2, these are both linear. Linear functions grow by a constant rate of change. So let's take either of these as an example. If they both have an initial amount of 2, that's their y-intercepts, this first graph would be going up by 10, so the next value would be 2 plus 10 would be 12, and then 22, and then 32, because you would keep adding 10. And for the second example, same thing, starts with 2, but now we're adding 8. So our y-intercept would be 2, and then we would add 8 to get 10, and then add 8 to get 18. So linear functions are formed by adding. Now exponential functions, we said it's all about multiplying. So let's look at this question a little bit, the table of values they're giving us. So they want to know which one would best describe this data. So if we look at these y values, we want to ask ourselves, are they indeed being formed through some kind of addition, which would make them linear, Or are they formed by some kind of multiplication, which would make them exponential, which now if we look at choices 3 and 4, both of these are in that format, y equals a times b to the x, which makes them both exponential. And when an exponential function, the way you can tell it's exponential is if x is in the exponent. So both of these have x in the exponent. This number 3 is saying we're multiplying by 2. And number 4 is saying we're multiplying by 5. So let's investigate. So if I wanted to get from 2 to 10, I could say add 8, but then is that consistent? 10 to 50 is not adding 8. And 50 to 250 is not adding 8. And it's certainly not adding 10. So we can get rid of both of our linear choices. So now, are we multiplying by 2 or by 5? Well, 2 times 2 is 4. So we're not multiplying by 2. So we must be multiplying by 5. So 2 times 5 is 10. Yes. 10 times 5 is 50. That works. And then if you weren't sure about the other ones, you could check in your calculator. 50 times 5 is going to give you 250. And 250 times 5 will give you 1250. Now the other reason this choice is our answer, the number in front, the 2, we said the a is your y-intercept. So you know you have a y-intercept when x is equal to 0. So if you look in your table, the y-intercept here is 2 when x is equal to 0. Okay, for the next question, you have 3 functions, and all I want you to do is identify the y-intercept and then tell me whether it's growth or decay. So I am going to ask you again to pause the video and try the question, and then I'm going to go over it. Okay, so I'm ready to go over it. So our y-intercept for A is going to be 8, since that's the number in front of our base. And because 2/3 is a number less than 1, that is going to show exponential decay. The y-intercept in B is 125, because again, that's the number in front of the base. And because 1.5 is a number bigger than 1, that's going to show exponential growth. And then the y-intercept in C is 56. And because 3/2, it is a fraction, but it's a fraction bigger than 1, that's going to show growth. And if you weren't sure with 3/2, you could turn that into a decimal, and that is also 1.5. Okay. Question number 5 gives us a breakdown of a sample of a chemical compound represented by this function, f of x equals 100 times 0.3 to the x power. F of x is the number of milligrams of this substance, and x is the time in years. They ask us to explain in this function what the 0.3 and the 100 represent. So, since 100 is in the y-intercept position, we could say it's the y-intercept, but sometimes with a word problem, it makes more sense to use the other thing we called A, which if I go back up here, we called it the initial value. So we can call it a y-intercept, but if we're talking about this substance, it might make sense to call it the initial amount of the substance. Now, if I take a look at the 0.3, the 0.3 is what it's growing. Well, it tells me that it's actually decaying, but 0.3 is my multiplying factor, is what I meant to say, not growing. So 0.3 we're going to call the multiplying factor. And if I did ask, well, does this multiplying factor show growth or decay? It does show decay, so if you wanted to add that too, you could. But that is how this substance is decaying. It tells us it's decaying because we see a number less than 1. Okay, now let's take a look at the next example. Which of the following could be the equation of the exponential function shown graph below? Then we're going to explain our choice. So I see a graph here that's decaying. So this is exponential decay. So that means the base must be less than 1. And that's because I see that it's a decreasing graph. So if I look at my choices, I see 2 choices already I can rule out because they have bases bigger than 1. Now I have 2 choices that could possibly be the case with different y-intercepts. So one is a y-intercept of 18 and one is a y-intercept of 40. They both have bases less than 1, so they both could show this decay. Now, if you look here, I can see my y-intercept is somewhere up here, and they do give me a number here, so to kind of put it into context, I know my y-intercept must be something a little less than 20, so now I know I must be looking at choice 2. So if I have to explain myself, which isn't typical of a multiple choice question, but we are being asked to do that, we're going to say since the graph is decreasing, our base is less than 1, and then since the graph is crossing the y-axis below 20, our y-intercept is a value less than 20, which is how choice 2 is the only reasonable choice. Okay, so at this point we've gone through the lesson. What I would like you to do, if you want to go back and read through any of the questions, check over your notes, you can. I've also posted the answer key to this lesson without the video on Canvas. Please try homework tonight, 11-1. I hope to be back in school tomorrow, so I will check that homework and we will move on to day 2. Have a great day, everyone.